PyCes is a security static analysis scanner for Python-based source code. PyCes is a product of deep research conducted into security issues in common Python frameworks like Django, TurboGears, Flask, and many more. By analyzing these frameworks, I've written custom rules that detect any issues that may arise out of inherent bugs, improper usage, or insecure open source components. Now, this is the manual for PyCes, and by running PyCes on a code base, the PyCes tool gives us a report that tells us first the type of code that is present, the presence of any third-party libraries or open source components, potential vulnerabilities that may be present in the code, vulnerabilities that are present in the open source components of the code, and also it greps and detects any vulnerable pattern that maybe need to be further analyzed by the engineer. By doing so, we get a comprehensive look of the code and the vulnerabilities which are present inside. So now let's see PyCes in action.
Now we will be running the PyCes scanner on a particular code base. So first, go to the GitHub repository, download the PyCes scanner to your local machine, unzip it. And once you unzip it, you should see something like this. These are the contents of the PyCes scanner. Go to the test project folder and paste your code base there. I already have a code base here. So now we'll come outside. The Windows users can use the run scan.bat file to automatically run the scan. Double click on the scan will get started. It'll pick up the code base and it'll give out the results. Now the Mac and Linux users can use the PyCes runner file. This file will again start up the scanner and put the results inside the results folder. Now once we run the scan, we will see that the reports have been generated over here. The PyCes report is generated in either HTML or PDF. So as we can see here, the PyCes report has been generated on the code base that was provided. Out of the contents, the first one is the output. It tells us the different types of code that is present in our code base, the number of lines that are present. Then it shows us the number of third-party libraries that are detected in the code. While this code has no third-party libraries, all these different libraries are detected in a code base if present. Now, next, the findings are presented. The findings are different vulnerabilities in the code base. They are categorized by their severity, their confidence, and their CVE numbers. Now, this is a low severity finding. And then there are also high severity findings. So the high severity finding here, for example, is a sub-process with a p open with shell equals to true, potentially allowing command injection to take place. It's present at these particular lines. And in this particular file, and opening that particular file at that line number will tell us where the issue exists. Now there is also dependency check output. This one scans the open source components and it tells us any findings that may be present. So this says that there are some published vulnerabilities and it gives us a description of what's present. And then then the tool also greps for any vulnerable patterns. These are the patterns that has been grepped in this particular file. So as you can see here, the finding name says reference to vulnerable algorithms or pickle library used. Now the use of pickle library is insecure. So the engineer can go to this particular file at this particular line number and check if this is still an issue. And this is a summary of the PyCes report. Thank you.